Reamplification. What is it? Is it a Netflix original series? Fancy new brand of soap? That cool new restaurant down the street? Well, no. Reamplification, or reamping, is an audio engineering technique where you run a line-level signal into an amplifier in order to re-record it with a different sonic character. Now, it sounds pretty handy if you ask me. You may have left your amp at your buddy's recording studio, or you are just far away from your regular recording setup. Whatever the use case may be, reamping is your friend. Unfortunately, I've seen a lot of misinformation, myths, and a lot of people trying to sell you stuff when it comes to this topic. So, in this video, I'll try to go over the basics of how reamping works, the problems it solves, and whether or not you should invest in a reamping solution for your setup. Not gonna lie, the answer may surprise you. I'm your host, and welcome
to the Filthy Branch.
The idea behind reamplification is pretty simple. We have this huge line-level signal and try to squeeze it into a regular instrument amplifier. Easy enough, right? Normally, guitar makes sound. Plug guitar into amp. You get more sound. So now let's use an interface. Seriously though, while in many instances that may be a good enough solution, there are a couple of caveats. Look at this graph, comparing the average amplitude of some common audio signal levels. Line level is kinda big in comparison to all those other options. Then, by connecting a line level source into a guitar amplifier, we're trying to fit a whole lot of signal into it, which may be too much for the power rails, causing clipping. Moreover, if you're trying to go into guitar pedals, the problem may be even worse, because they work with a much more limited headroom. So, we've identified one problem. Let's add it to a list. But we still have to deal with something I mentioned before, ground loops. Say, you're recording a hit new single. You get your guitar or bass ready and start recording. Only your plugins ain't cutting it this time. You need that warm, analog sound of a real amp. No problem, you run a cable from your interface to your amp on the other side of the room. You connect them together and... Wait, can you hear that? That is a sound of failure. Well, not really, it's just a ground loop. Now, I could try to give you a masterclass on how ground loops work, but this isn't a channel about power electronics. Although, if you want to learn more, I'll leave some cool videos you can check out down below. But for now, I'll give you a simplified version. You have electrical things A and V, each with their own ground. If you've seen my previous video, you'll know that ground is just a reference point, where we assume there's little to no electric potential. Now, by connecting thing A to B, we are also connecting their grounds together. But here's the catch. Thing A gets its ground from this outlet, while thing B is connected across the room to this outlet. Both of these lead back to your breaker box. And that's a problem, because, for simplicity's sake, ground A has some more cable running back to the breaker box, while B sits a little bit closer to it. And because of this, they sit at slightly different points within that ground potential. Let's say 0.1 and 0.4 volts, respectively. And so, because there's a difference in potential, current starts flowing. Not only that, but in unbalanced circuits, that ground is being used as a reference point for the actual signal being amplified. And so, you get that ugly hum at around 50 to 60 Hz. Now, in reality, it's a bit more complicated. You may not even need two different outlets in order to create a ground loop. But hey, as long as you're not trying to become a certified electrician or an electrical engineer, you should be fine. So, let's add ground loops to that list. But the problem just won't stop coming, because now I want to connect a mixer to my amplifier. But I only have some of these weird connectors. So what's going on here? See, this mixer has balanced outputs and uses a connector called XLR. And our pedals and amplifiers, all of those are unbalanced. And they use good old TS connectors. Meaning we have to find a way to unbalance this connection. So let's add it to the list. And finally, there's the elephant in the room. Impedance. This may seem like a scary subject, but I promise you it's not, for this use case. And I'll just go ahead and say this. You don't need to match your source impedance if you are going into a high impedance input stage. Let me repeat. You don't need to match your source impedance if you're going into a high impedance input stage. And to understand why, first you need to get a hang of how the inverse process works. I mean, you don't have to, but it's much more intuitive if you do. So here's when you do have to worry about impedance in audio. If you have a high impedance source, such as passive guitar pickups, you can just connect them together, yeah, but you are creating a couple of problems. Here's this diagram of how it all kinda works. This AC voltage source is the audio coming from your pickups. This huge resistor is modeling the signal's output impedance. And this other resistor is modeling the impedance of the input stage you're going into, which is also kinda acting like a load on your source. Now, can you see this right here? Whenever you have two resistors connected like that, That's called a voltage divider, which drops your overall signal's amplitude. And as this input impedance gets lower, you get less and less signal from your source. Now, having said that, why do I say that you don't need to match your source impedance if you're going into a high impedance input stage? Now, if we go back to that model and replace this resistor with a much lower value, and this one for a much higher one, we're still getting a divider, but it's not affecting the signal as much. So for your regular day-to-day reamping, do you need to worry about the output impedance of the circuit? The answer is it depends, but most of the time not really. Having said that, a high output impedance is a real nice bonus to have in any reamping solution, mostly because there are circuits out there that are designed to load your pickups, namely things like a fuzz phase or some other guitar pedals. Check out this video by JHS if you want to learn more. But going back to reamping, here's a list of things that a reamp circuit should be able to accomplish. It needs to provide us with a way to lower the gain of the signal, also provide us a way to eliminate ground loops, allow us to unbalance the signal, and, as a nice bonus, provide us a high impedance output. And so the question is, which circuit could solve all of these problems? I mean, a voltage divider will lower the gain just fine, and we'll definitely get that impedance up if we use some huge resistors. Maybe we can go down the route of using weird cables and adapters in order to unbalance the signal, but still the most difficult thing we'd have to accomplish is getting rid of those ground loops. And so, the answer is most of the circuits you'll find online if you look up Reamp box schematic look like this, just a transformer with a couple of connectors. So how does it work? Well, transformers use inductors, electromagnetism, and probably black magic in order to get an AC signal from the primary into the secondary without ever having to connect them directly, effectively isolating the circuit. Luckily, some more people have already thought about this, and now you have a couple of solutions. You can buy a Reamp box, get a passive DI box, and wire everything backwards, build your own Reamp box, and the mysterious option number 4. Let's take a look at each of these. This is a Walrus Audio Canvas Reamp box. This is not sponsored in any way, I got this with my own cash. And you too can get one for the low price of 150 bucks at the time of recording. But is this a good investment? Does it even work? I took the thing apart and then spent an entire afternoon tracing the signal path and ended up with this, my take on what the circuit is actually doing. Also, I'm censoring all of the values in this schematic just because I don't want any lawyers going after me. But here's the breakdown. We got some input and output connectors, no surprise there, a bunch of switches that toggle a high-pass filter, a phase flip, a mute toggle, and a ground lift, plus all of the components that actually make this work. I also took a bunch of measurements for frequency response and harmonic distortion, and the results are shocking. Here's the frequency response graph for this Reamp box, both using the high impedance input stage and the low impedance input stage, toggled using this handy switch at the interface. And honestly, it looks pretty decent. The response is mostly flat up until 10 kHz. This is where you get a little bit of a bump, what some people may call air or clarity. Also try to have a look of how transients may behave with this guy by using my oscilloscope and a square wave. It's mostly fine, although it does have a little bit of resonance, but that's just how transformers work. So this box right here is pretty decent, but you still have more options. If you are into audio as much as I am, you've probably heard about this. Given that a passive DI box and a Reamp box are mostly the same thing, just a transformer with a bunch of complementary components. For the DI, you're trying to get a high impedance source into a low impedance input, which functionally is just the opposite of what a Reamp box is trying to do. And because these are all passive circuits, there's nothing stopping you from using this guy backwards, effectively converting the DI into a Reamp box. But that just begs the question, why? We know the Reamp box works just fine, so why go through all this trouble? The answer, as always, is money. Given that the market for DIs is just massive, you can find these guys for much cheaper, up to 10 times to be exact. And that seems like a pretty good deal if you ask me, but is it up to the task? Here's the results. Here's the frequency response for the DI box wired backwards. It's not looking too hot, right? But do you remember what I said before? You don't need to match your source impedance if you're going into a high impedance input stage. What if we just connect the DI the right way? Of course, that means we have to convert the XLR into TS in order to actually make it unbalanced. And if we run the test again, we get this. That's pretty much flat all over the entire frequency spectrum. Plus, the signal is already being dropped by like 20 dB. And so, I also mapped out the schematic for this guy. As expected, it's a much simpler design. You probably just don't want to engage the pad switch because it creates this weird high-pass filter, but overall, it's a pretty decent choice. Of course, we're lacking the impedance matching that we had with the Reamp box, and so we may not be able to run the signal through a fuzz phase anytime soon, but for general purpose, day-to-day ramping, should do just fine. Plus, we are actually getting a ground lift, but we still have to take a look at two more options. We've already taken a look at both of these circuits, so what's stopping us from just making our own? Well, nothing really, and that's exactly what I did. This design is centered around these super cheap 1-to-1 transformers I found online, and it's pretty simple. We get a signal in, we assume a low impedance here at the primary, we run it through the transformer, and we connect the output to an amplifier, which should be a high impedance input stage. Now here's the transient response for this transformer. It isn't looking too great, but that's alright. Found this video of a guy creating Sobel networks in order to properly load that transformer, and you can check it out down below. And through my testing, I found that these values at the secondary will really help out. And here's the results. That's a fairly decent frequency response, even if the transformer does introduce a subtle low-end roll-off, just below 60 Hz. Anyways, this DIY option does accomplish the points mentioned in the list, plus the whole build cost me like $5. But if you already own a guitar pedal, who says that you even need to consider these options? That's right, folks. We are already on to the mysterious option number 4. You may have come across this video in your feed, where our friend tells us that you can just reamp using any Boss pedal, and for the most part, yeah, he's absolutely right. In fact, any pedal with a buffered bypass will do. And here's a frequency response for one of my own pedals. It's pretty good, although you do get that signature Boss high-end roll-off. The only real disadvantage is that we don't get that bonus impedance emulation, but once again, for basic day-to-day reamping, it will work just fine. I kept on mentioning the harmonic distortion measurements for each of those options, but really the only interesting ones were the one from the DIY Reamp and the DI box wired backwards. But anyways, here's a spreadsheet with all of the results I have. I took the geometric mean total harmonic distortion, that's just even and odd combined and compensating for any weird peaks. Sorted the options from best to worst performer, where a lower percentage is better, and also added the worst case scenario, the worst performing frequency with how much distortion it added to the overall signal, plus the dominant type of distortion over the entire spectrum. That would be even or odd. Right at the top, with the best performance, is a cheap DI box with little to no distortion when wired correctly. Then there's this mysterious circuit I built for a future video, followed by the proper Reamp box driving a line level input, then the same Reamp box but driving a high impedance input for some reason, followed by the bypassed Boss pedal, next the DIY Reamp box, and finally the DI box wired backwards, which was the worst performer for distortion and frequency response overall. And you can also find all of these results over at my website, fractalmusic.com. Alright, so I've been yapping about frequency response graphs, percentages, distortion, and all of that for quite some time now, but who cares, right? How do these options sound? So here's a little demo I put together so you can judge the results by yourself. So here's the setup. We got this guitar sample, going through my NetJack setup, into this laptop, onto the aux output from my XR18 mixer, into the different Reamp solutions, which then goes into my Fender Frontman's 212's clean channel and recorded by this E609 microphone. All of the knobs are set to noon so that the tone stack doesn't color the sound too much, and here's how it sounds. Now we have this distorted sample through the exact same setup. And now this synth sample. Also for bass, we have a second setup. We have this bass sample through NetJack, out the laptop, onto the XR18, then through the Reamp solutions, onto a Fender Rumble, all knobs set to noon, no contour, using the clean channel, and captured by this SM57 microphone. If you want to take a closer listen to each of these, you can always find a full breakdown over at my website, fractalmusic.com. There are many producers that dislike reamping as a concept. They'll tell you that you need to capture everything right at the source, first time around. And that sort of mindset is alright, you do whatever gets you the results. But on that same note, maybe you're much more comfortable writing and composing in your bedroom. That's what gets your uses going. Maybe you don't have access to an amplifier 24/7. Maybe you don't even have a microphone to begin with. Or maybe you just want to experiment and run your drums, your vocals, all of your instruments through a guitar or bass amp. Whatever your use case may be, you deserve to know that you have options. Don't go out and buy something just because the guy who sells the damn thing tells you that you need it in order to record good music. Also, I'm not claiming that commercial solutions don't work or that you have to boycott these companies, because the solutions do work. Just look at those graphs. If you can afford something and you think it's gonna help you out in the long run, just go ahead and buy it. It's your money. At the end of the day, the reason I'm making this video is to empower you with knowledge, that data, in order to make informed decisions. Your own decisions. And if I manage to get you into DIY audio electronics, then that's also great, because it's a great hobby to have. Also, if you are like an actual electrical engineer, just please don't kill me. I'm trying my best here. However, if I did get anything terribly wrong, just let me know and I'll leave any corrections in the pinned comment down below. But anyways, that's it for this video. If you enjoyed your stay here, just do the things. Also visit my website and let me know what you want to see next.
Okay, love you, bye.